Picture a downtown office tower on a hot August afternoon. A single temperature sensor freezes at 72 degrees. The BAS thinks a zone is fine. A VAV damper drives open. The economizer cycles oddly. And 30 minutes later, the chilled water plant trips because the systems have been fighting each other. Tenants call, teams scramble. What started as a $15 part becomes emergency overtime and a backlog of service tickets. Welcome to Built, Wired, and Secured. I'm Alex Morgan. In today's episode, we're discussing quiet cascades, stopping small failures before they become building outages, what they are, why they matter, and what decision makers should do to stop the dominoes. Joining me is Michael Harrington.
Thanks, Alex. Good to be here. Right away, I ask teams one blunt question. What breaks if this goes down? If you can answer that for a component before it fails, you're already halfway to preventing the outage.
Right. Quick rhetorical question for listeners. How often are we propping systems up with duct tape and hope? Because that's the atmosphere where these quiet cascades live.
Exactly. In practice, 3 categories start most cascades: sensors and field devices that give bad data, power handling hiccups like imperfect UPS transfers, and human or contractual handoffs, unlabeled panels, unclear scopes. Any one of those can be contained. 2 or 3 together create the chain reaction. Tenants feel the outage first. Owners feel the balance sheet hit later.
Got it. So why do these small things chain so effectively? Is it design choices, procurement, or day-to-day ops?
All 3. Design that prioritizes integration without clear isolation creates hidden dependencies. Procurement chasing lowest first cost skips spares and labeling. Operations without an ownership map, who answers at 2 a.m., ends up passing responsibility back and forth. From an operational standpoint, those 3 together are a recipe for cascades.
Let's push on redundancy a bit. People assume adding redundant systems always reduces risk. Isn't redundancy the whole point?
Redundancy is a tool, not a panacea. If you add a second controller, but both rely on one flaky power transfer switch, you haven't actually reduced outage risk. You've added more to manage. That's fine until it fails.
If the backup shares that same transfer switch, haven't you still reduced risk?
No. The shared transfer switch is an unaddressed dependency. Worse, poorly documented redundancy creates false confidence. Teams assume the backup will kick in and they stop testing it. So redundancy must be validated and explicitly owned, or it becomes a stealth single point of failure.
Got it. Okay, walk me through operational controls that actually interrupt a cascade. Not platitudes, concrete things teams can start this week.
Start with telemetry sanity checks. Don't just collect data. Watch for impossible values and cross-validate sensors.
Wait, what do you mean by cross-validate? Give me the simplest check I can set up this week.
A quick rule. If 2 independent measurements of the same physical thing disagree by more than 10%, trigger an investigation. That one simple threshold catches a lot of frozen or drifting sensors.
Right.
Next, spare parts strategy. Keep the top 3 low-voltage parts that fail most often on-site, tested and labeled so swaps are fast. Then validated failovers. Schedule low-impact failover tests quarterly and document who did what and how long it took. Finally, create a visible ownership map that both tech and facilities can access, and run low-disruption tests. A planned 30-minute window beats a surprise outage any day.
Got it. Can you give a compact example where these controls stopped a cascade in the wild?
Short version, hospital campus, chilled water plant tripped repeatedly. Telemetry sanity checks showed a supply temperature sensor intermittently reading flat lines. Because the team kept a labeled spare sensor kit on site and had a 30-minute low-impact window scheduled, they swapped the sensor, re-ran the failover test, and the tripping stopped. No capital overhaul, no tenant disruption, just diagnostics, a tested spare, and ownership.
Give me the flip side, a short example where vendor handoffs made things worse.
Office park with 2 vendors sharing access control and network duties. Each assumed the other handled firmware updates for edge devices. During a power event, an authentication bug surfaced, and neither team stepped in. Access was lost for hours. An ownership map and a contractual who does firmware clause would have prevented it. Clarity matters as much as technology.
Right. Before we wrap, give listeners 3 things they can do this week to reduce cascade risk.
Absolutely. 1. Run a 5-minute ownership map review. List the top 10 components that would cause tenant impact and name the owner for each. 2. Pick the sensor type that fails most often and verify you have at least one tested spare on site. 3. Schedule a low-impact failover test this quarter and document the results and lessons learned. Do those 3 and you'll head off most quiet cascades.
One brief disagreement listeners will like. You said redundancy can be risky if not maintained. Is there ever a case where owners should add redundancy even before ops are ready?
Marketing and risk requirements sometimes demand redundancy. My rule of thumb, only build redundancy when you've budgeted the people and processes to validate and maintain it. If you can't, invest first in telemetry checks, spares, ownership maps, and tests, then add redundancy as a second step. Otherwise, you may buy complexity that hides failure modes instead of reducing them.
Solid. Quick recap for listeners who want to act right now. Map ownership for critical components, keep and test spares for the usual suspects, add sanity checks in telemetry with a 10% disagreement trigger, and validate failovers on a schedule. Prioritize controls and tests before doubling down on complexity.
Exactly. Small investments in process and a few spare parts often give the biggest reduction in outage risk. Ask every quarter, what's the smallest failure that would cause the biggest impact? Fix that first.
If you want a practical next step, we've put a 1-page cascade checklist in the episode notes, an ownership map template, a spare parts starter list, and a 30-minute failover test plan. Download it, run the quick checks this week, and tell us what you found on the show page or via email. We'll follow up on listener stories in a future episode. That wraps up this episode of Built, Wired, and Secured. Today we explored how tiny failures quietly cascade into tenant-impacting outages, and why simple, owner-focused controls beat complexity when it comes to resilience. Thanks for spending a few minutes with us, Michael.
Thanks, Alex. Take the checklist and actually use it. That's the difference between advice and prevented outages.
Until next time, make sure the systems you're responsible for are built to last, wired with intention, and secured for the real world.